Hello students, this is the recording for the 5A lesson on electricity and magnetism. So go ahead and think really quick to yourself, a little bit of a brain stretch. What kind of things have or use electricity? Pause the video, continue playing when you have a few answers in mind. All right, so let's go ahead and talk. Let's go ahead and talk a little bit about things that use electricity. Right, one of the ones that I hear most often are definitely phones. Right, we charge our phones with electricity. Anything that has batteries. Right, so things like cameras as well. Those things often get charged nowadays using electricity. Things that get plugged into the wall. Right, so things like TVs and computers. We can think about like fans, right? A lot of our wiring in our house, so like ovens need to be plugged in, refrigerators, etc. There's tons and tons of things around us that use electricity. So hopefully you thought of a couple of those, or you thought of some original ones. Today we're going to be taking a look at electricity and magnetism. So let's go ahead and take a look at our schedule here. There are only 10 days left of the school year, and then courses are over and you will not be allowed to submit anything past the final deadline. So today is Tuesday. We are jumping into unit number 5, our last unit. This unit is only 4 lessons long, so we'll be talking about electricity, magnetism, motors, circuits part 1 and circuits part 2. And then don't forget that you do have your last exam here, your only exam, units 4 through 5. This will be due on Wednesday. It won't be zeroed out until Thursday though, so you have a bit of a grace period before it gets zeroed out. Don't forget that the last Star 360 assessments are for today and tomorrow, so Wednesday should be tomorrow if you're watching this video on time, and that'll be during period 3 for your math Star 360. Remember that this is worth 5% of your overall grade in every single class, so even in PE, science, history, etc. you still get 5% just by doing both the reading and the math. You do have to do both of them, otherwise you will not get full credit. Again, it's just a completion grade, so make sure you get them done because it's an easy way to boost your grade in every class. Don't forget that, again, we did originally have an exam for Tuesday. However, we have switched that up just so that it doesn't fall during Star 360. So again, we're going straight from Unit 4 into Unit 5, and we will do the Unit 4-5 exam on Wednesday, Thursday, and then you'll have a week to make up any missing work. Again, you should be focusing on the Units 1, 2, and 3 projects, and then the unit, and then that last exam. All right, these are worth 70% of your grade overall, which means that each individual one is worth 17.5%. It's literally impossible to pass the course without doing these, so please make sure you get them done. Otherwise, you're wasting your time, you're wasting our time. So please, if you're behind, don't try to do 100 notes because each note is worth less than 1% and you're really just wasting your time. Please focus on the projects, please do them correctly. Watch the recordings. The recordings go over everything you need in order to be successful. If that still doesn't work, then you need to contact Mr. Bangle. So remember that I am now on maternity leave. I am not available. If you do need anything, help with like the course and stuff, please reach out to Miss Smith, who is your substitute if you are on my roster. Otherwise, if you need actual tutoring on the projects, please contact Mr. Bangle. He's going to be our science guru while I'm out, as well as the fact that he's already very familiar with the projects. So please make sure to contact him at this information here if you do need help on those projects besides what the videos give you. Again, you should always watch the videos first, come to tutoring having watched those videos. That way you can explain exactly what you're stuck on, and it's not just sitting there being like, I don't know what to do. You need to go ahead and do some of the work before you're asking for help, because otherwise it just seems like you just want answers. So please do some of the work, meet us halfway, and then make sure that you reach out if that still isn't enough. Okay? So today we're going to go ahead and take a look at electricity and magnetism, talk about how magnetic poles interact and how electric charges interact. And we will be working in our 5A notes, so if you haven't already, make sure that you get those 5A notes open and ready to go. Remember that if you miss class, they are in the grades tab, so please make sure that you go to the grades tab. Everything that you need is there for everything, including those projects that I mentioned earlier. So what I want you to go ahead and tell me is what do you notice happens when you bring two magnets close together? And I'm going to go ahead and open up this GIF so that you can see it and make some observations. All right, so taking a look here, you can see two examples. So on top, you see two magnets. On the bottom, you see two magnets. Go ahead and observe what do you notice is happening in both of those scenarios. Pause the video, continue playing when you're ready with an answer. All right, well, hopefully what you noticed is that on the top example, these blue magnets were actually pushing each other away, and we'll talk about what that vocabulary term is in a little bit, whereas the ones on the bottom, these pink magnets, actually wanted to stick together. So we'll explain this a little bit more closely. You're probably pretty familiar with how magnets work. Just throughout your life, you've interacted with magnets at some point. But again, we can see that they can either push each other away or they can come closer together and stick together. So let's go ahead and talk a little bit about some stuff that we kind of need to know in order to better understand electricity and magnetism. So first, to understand physics, it's helpful to understand a little bit about chemistry. Now, if you've taken a chemistry course before, this should look familiar, but otherwise we're going to review it just to make sure that everybody has the same basis here, okay? So all matter, all right, which means physical substances, including gases like air. Air is a physical substance even though we don't see it. Liquids like water or solids like metal, right? All of those things are physical substances. They are made up of small building blocks called atoms. Atoms are the smallest complete unit of matter. They are what make matter, build matter into what we see, okay? Now, the structure of an atom has three main parts. It has protons, neutrons, and electrons. Now, the protons and the neutrons are in the center right here, which is called the nucleus. So you can see that word right here. You can see them kind of hanging out in the center right here in the nucleus. Now, protons are positively charged. The way I remember that is pros are like the good things, pros and cons. Pros are good. And so those ones are the positive charge. They have a +1 electric charge, which we're talking about electricity. So you just heard me use the word electric. Now, neutrons, on the other hand, you can see here in red, neutrons don't have a charge. They are neutral, which should make sense because they literally start with the same 5 letters. Neutral neutrons. Neutral neutrons. Right, so these have 0 charge. Now, everything in our nucleus has mass, meaning that it has like weight to it. And so therefore atoms do in fact have mass. Again, they're physical substances. Now they're really, really tiny, so we don't really notice their mass. Again, like we don't really notice the mass of air. And if I were to take a single atom, you wouldn't notice the mass of a single atom. But once you have enough of them, it builds up, and if they're in like a solid form like your desk or your computer or yourself, right, then you notice that they have actual mass or weight, okay? Now, electrons, on the other hand, you can see over here in green, electrons are the last type of particle, and they orbit, meaning they rotate around the nucleus. These have a negative charge. Makes sense. We have a proton that's positive, a neutron that's neutral, so we should have something that's negative to balance that all out. And so they have a -1 electron charge. You'll also know electric charge. You'll also know that the word electron looks a lot like the word electricity. Again, hint, hint. This is where we're going with this. Now, electrons are actually super, super tiny. So their mass is almost non-existent. It's very, very tiny. It almost does not matter, okay? And the result is because they're so tiny, they can actually fly extremely fast. So they are moving very, very fast around the nucleus, whereas these protons and neutrons are significantly heavier in comparison to the electrons. Even though they're tiny, they're much heavier than the electrons. And so those ones are unable to like fly around quite as easily as the electrons. All right, so this is going to be our answers to number 2 and number 3. Again, building blocks are called atoms. Capitalization does not matter. Spelling does. Only put in what's in the red box. Same thing with nucleus. That center part is called the nucleus. Make sure you spell it correctly. Pause the video. Continue playing when you're ready. All right, so at this point you should be able to think of the correct answer here. So what is the particle in an atom that is negatively charged, has almost no mass, and orbits around the nucleus? Again, the word orbiting, meaning it's on the outside of the nucleus flying around. Go ahead, pause the video, think of the answer, and continue playing when you're ready. Well, hopefully this is something that you should be familiar with because we just reviewed it. The correct answer here is electrons. Again, electrons have a -1 electric charge. They are very, very tiny, allowing them to fly, and specifically fly around the nucleus, orbiting. Go ahead, pause the video, and continue playing when you are ready with number 4. Okay, so let's go ahead and talk about what does this have to do with electricity? Well, here's the deal. The definition of electricity is the flow or motion, movement of electric charges. And we just talked about electric charges. We talked about how protons have a positive electric charge, neutrons are neutral, and electrons are negatively charged. Now, what happens here is that these moving charges, positives and negatives, are where electricity comes from. So an example here is lightning. Lightning is a natural example of electricity. And so what happens during lightning is that clouds, as they kind of collide and move together, create a buildup of electricity. And so the result is that we end up with some electric charges in our clouds. Now, specifically, the positive charges kind of line up at the top of the cloud, whereas the negative charges line up at the bottom of the cloud. And then what happens is that charges underneath on the ground also build up. We're going to learn a little bit later that opposites attract. So since there's a lot of negatives at the bottom of our cloud, they are beginning to attract positives within the ground. And as that happens, eventually they overcome the resistance from our atmosphere and they actually run towards each other and collide. And that collision is what results in lightning. It also results in a loud sound, which is the thunder that you hear. So let's go ahead and take a look at a GIF of this. So let me go ahead and grab this one. I'm going to go ahead and zoom into this. Let's take a look here. All right, so again, what we can see here is that as clouds are colliding with each other, rubbing up against each other, again, we end up with a bunch of negative charges building up at the bottom here, which begins to attract in the ground the opposite, which is positive charges. And at some point, we overcome the air, and these two things collide together. All right, and as they collide together, that creates lightning, a natural form of electricity. Again, a natural form of moving electric charges. Okay, now there's another type of electricity that you might have heard of. This is static electricity. So for example, if you've ever rubbed your feet on your socks on your feet on a carpet and then touched someone, you probably shocked that person. Or if you ever went down a slide at the park and then touched someone, you shocked them. Or for example, if you had plastic chairs in school and you rubbed your shirt against them, you could then shock someone. So this is all called static electricity. Fun to play with in small amounts. So static electricity is when the electric charges are not actually moving, but they begin to build up in a material, and eventually they move when you shock a person, for example. All right, but the static part, static means stays. Okay, those things start with the same three letters. So static, stays, all right, in place, okay? So overall, the material has what's called a net or overall charge. So overall, because of the buildup of either positive particles or negative particles, your material ends up being overall positive or overall negative. And this happens when objects give up or gain electrons, right? We talked about how electrons are the -1 charges. Again, they're super tiny, so they're really good at moving, right? So they can move from one place to another. So if you lose electrons, you actually become overall positive, all right, because you're losing negativity. Whereas if you gain electrons, which are negative, you're gaining negativity, and so you become overall negative. And again, once things are begin to touch, then those charges can begin to travel, and that is where you get a shock from, an electric shock from, when you are dealing with static electricity. Okay, so you can see some examples here of how you can build up static electricity. We mentioned some. So this right here can transfer electricity to you, and you can see her hair standing up, right? So that's an example of the build up of static electricity in her hair. Again, anytime you rub a material, you rub materials together, so like a balloon and a cloth, that also creates static electricity. You can also rub a balloon against your hair, for example, and then your hair will be attracted to the balloon. That's also static electricity. And the cool thing is that static electricity even works on things like water. So let me go ahead and show you what this one looks like. Oh, sorry, let me get the other one. All right, so what you can see here is that they are building up static electricity in this balloon by rubbing it with a piece of fabric. That means that electrons are being transferred and building up in our balloon. And what happens is that this can actually come in and attract water. Now, the cool thing about water is that water does have a partially negative side and a partially positive side. And so what happens is that this balloon is going to go ahead and attract some of those partials charges that are oppositely charged, which makes the water begin to bend towards it. So pretty cool phenomena there that even water can be attracted to static electricity. All right, so at this point you should be able to, sorry, let me go back to here. At this point you should be able to answer these questions on your own. So go ahead and pause the video. Think about what is the definition of the nucleus, electricity, static electricity, and electrons, right? So which of these are negative charges with negligible, meaning almost no mass, in the orbit of an atom? Which one is the flow or movement of electrical charges? Which one is the center of an atom made up of protons and neutrons? And which is what occurs when a material has a net overall charge, but the electric charges do not move, they stay in place. Pause the video, continue playing when you're ready. All right, so taking a look here, you should have been able to determine that the nucleus is the center of the atom. Electricity is the flow of electric charges. Static electricity is when you end up with a charge, but those charges stay in place for a little bit until eventually they flow, causing an electric shock or the transfer of that electricity. And electrons are negative charges. Again, we kind of went over this earlier. They have almost no mass. They are orbiting. Again, they have the same root, right? Electricity, electrons, right? So this should keep in mind that electrons are really important to electricity. All right, I did mention we are also going to talk about magnetism. We saw a brain stretch today about magnetism, a brainstorm about it. So let's also talk about magnetism. So magnetism is a force that can attract, or meaning pull something closer, or repel, meaning push something away, if it has a magnetic material, right? So for example, magnets don't work with everything, right? They don't work with like wood, for example, because wood is not magnetic. But they do work with a lot of metals because a lot of metals are in fact magnetic. Now, you probably know at this point that magnets have both a north pole and a south pole, and you might also be thinking like, hey, those words sound familiar, and that's because the Earth, for example, also has a north pole and a south pole. Now, the reason a magnet has a north pole is because north poles of magnets will naturally want to point towards Earth, or Earth's geographic north, towards where Santa Claus is, okay? Whereas the south pole of a magnet will prefer to point towards geographic south of the Earth's, to Earth's geographic south pole. Okay, and you can see here again that right, so here's a magnet, right? So we can see a magnet and a compass kind of interacting, and compasses actually have magnets in them, which is why they work. And we'll talk about the Earth's poles in just a moment. Let's go ahead and take a look here. So again, what you can see here is that there's this idea of attraction, right, where we can see that a compass is going to go ahead and be attracted to the different parts of a magnet. Okay? All right, this is going to be the answer for number 6. Go ahead and fill in the blank with the word force, only the word force. Pause the video, continue playing when you're ready. All right, so here's the deal though. This is a little bit tricky because if the north pole of a magnet is attracted to Earth's geographic north, then the geographic north is actually acting like what pole of a magnet? Now here's the important part. Remember that opposites attract. So if the north pole of a compass is attracted to something, then it should be attracted to the opposite, which is what pole? Pause the video and think to yourself. Yeah, so if the north pole of a compass magnet is attracted to something, then it should be attracted to the south pole of something else, right? So if this is a magnet and this is the north part of our compass, sorry, let me get a different color here. So, oops, let's do green. So here's the north pole of our compass, south pole of our compass, right? You can see that the north pole of the compass should in fact be attracted to the south pole of another magnet. So what this means that if the north pole of a compass is pointing towards geographic north, then geographic north must actually be the opposite magnetism. So this actually is acting like the south pole of a magnet. Okay, let's go ahead and take a look at what that looks like. Okay, so let me move on here. All right, so what you can see here is that, again, if I have a compass, all right, so if this is my compass, then the north part of my compass will be pointing towards the North Pole, obviously. All right, but again, the North Pole actually is acting like magnetic south. You can see that in order for these two things to be attracted, they have to be opposites. So the north part of our compass has to be attracted to the south pole of a magnet. So this means that Earth's geographic north is actually acting like magnetic south, the south pole of a magnet. So this is kind of crazy to think about. All right, so geographic north pole actually acts more like the south pole of a magnet. This is number 7. Pause the video once you have filled that in and continue playing when you're ready. All right, so let's go ahead and talk a little bit more about this. Again, we have this idea that likes attract and opposites repel. We've kind of learned that throughout our entire trimester. So let's go ahead and practice this. So you should be able to determine are north and north, two north poles, are they like or opposite? And therefore, will they attract or repel? Same thing with here, north and south poles of a magnet, and then south and south. Pause the video, go ahead and answer all of those, and then continue playing when you're ready to check your answers. All right, so taking a look here, you should know that the North Pole and the North Pole are like poles, and therefore they are going to actually repel each other. Again, this is just like what we saw in one of our things here, right? We saw in the blue example that those are both magnetically the same pole. They must either be both north and north or both south and south. So because they're like poles, they are repelling or pushing each other away. Now, north and south, on the other hand, are opposites, and if they're opposites, then they are going to attract because opposites attract. So that must be more like our pink example down here, where one of these must be north and one of these must be south, or vice versa. This one's south, this one's north. Either way, if they're opposites, they're going to be attracted to each other. And finally, south and south, I mentioned, are also examples of like poles, and so again, those ones will actually repel from each other. All right, now electric charges, because again, we're talking about both magnetism and electricity, electric charges actually follow the same exact concept. So like charges also repel, just like poles repel, and opposite charges also attract, just like opposite poles attract. So go ahead, try this same exact thing, but now with different charges, positive and negative charges, positive, positive, negative, negative. Pause the video, continue playing when you're ready. All right, so taking a look here, you should have noticed that, again, positive and negative are opposite charges, and we know that opposites attract. And both of these last examples, we have like pairs, right? So positive, positive, those are like, negative, negative, those are alike, and therefore, in both of these scenarios, these charges will actually repel each other. All right, so at this point, you should be able to go ahead and do question number 8 all on your own based on that. So you have two positive electric charges that are brought close to each other. Therefore, what will happen? Will they attract? Will they repel? Will they not interact? Will they attract then repel, or repel then attract? Again, if you need help on that, just go back to the previous slide in this recording. Pause the video, continue playing when you're ready. All right, so today we talked about electricity and magnetism. We're going to talk about how those two things interact with each other tomorrow in motors. Again, it does seem kind of weird to talk about them the way that we did, kind of separately, but they are actually related to each other. We talked about magnetic poles and how they interact. Again, likes repel, opposites attract, and same thing with charges. Likes repel, opposites attract. All right, you should have been able to get an 80% or higher on your 5A notes. Make sure, go ahead, pause the video and rate yourself on your understanding. If you feel like you are over here in the very confused or still need some help area, please again make sure that you contact Mr. Bangle for some individual tutoring. Again, especially for projects and eventually that exam, which is going to be worth 70% of your grade overall. All right, he can help you tutor you through any of the science specific stuff for this course. Okay, and at this point, you should be able to submit your notes, and I hope you have a wonderful day. Thank you, everyone.